Dear students, in this video we are going to see how to design a bistable multivibrator by using multisim tool. So generally bistable multivibrator having two unstable states. So that means this circuit which uses two transistor, if the first transistor which goes to saturation and second transistor in cutoff, or the second transistor goes to saturation at the time first transistor in cutoff. So simultaneously it is not possible to make turn on or turn off both transistor. It is not possible. At least one transistor is in on case, at the same time the other transistor which is in off state. So this state changes continuously occurs, so that we are having the continuous square waveform at the output side. So this circuit which comprises two NPN transistor and required number of resistors, and we have input function generator and CRO and biasing unit. So let me start our circuit construction process straight away from selection of transistor, and we need a transistor. So transistor belongs to NPN category and their specification BC 547A 547A, yeah, transistor 1 and transistor 2, and we required 1, 2, 3, 4 number of resistors. 1, 2, 3 and 4. So 4 resistors are obtained, and we need a biasing unit, input section, output section and ground terminal. So we required a biasing. So in sources, power source, DC, so DC biasing we have applied, and input section and output section, and of course the ground terminal also we require. So ground terminal is selected. Now if you look at the connection of bistable multivibrator, both transistor having back-to-back connection. That means emitter of first transistor connected with emitter of second transistor, and base of first transistor connected to collector of second transistor. Similarly base of second transistor connected to collector of first transistor. So that here we are going to change the direction of second transistor. Now both transistor having their respective position, and we are going to connect each other. So now the emitter of these two transistors are connected. So first transistor as well as second transistor, both terminal emitter are grounded. Okay, then so in first transistor, in a collector terminal we have 1 kilo ohm resistor. So we have a 1 kilo ohm resistor that is connected with respect to first transistor. Okay, then from the same point we are having another 1 kilo ohm. The other end of the resistor goes to base of the next transistor. So we have a transistor, that other end goes to base of second transistor. Similarly the same kind of procedure we are following the second transistor also. It's connected. one end is connected and other end is connected to okay. So now collector terminal is both transistor are connected with respect to the respective resistors 1 kilo ohm, and these two resistors are connected with each other. So these two resistors are connected, and at this center point we are having connection with biasing of 12 volt. Yeah, the center point we are having connection of positive terminal of 12 volt of battery, and the negative is grounded. Okay, so we have to use the common ground terminal only, and we are applying the and the common ground terminal. Since we are using two transistor, so two number of channels we are using, so this may belongs to first transistor output, and this one we are going to take the second transistor output, and the common ground point, and this is also going to be grounded. So now once again we have to verify your connection. Okay, then we have to set the input, so 10 Hz, and the respective peak voltage we can fix 2. So now we have to verify the output of both transistors. As you can see, we are having the square waveform, and if you adjust the value you can easily identify. So we have two outputs, one is from the first transistor, another is from the second transistor. So it is already we know it is a kind of square waveform generator. Thank you, students.